Alright, let's solve my 6th day of the Leetcode problem. So, the Leetcode problem is finding the minimum in rotated sorted array. So we are supposed to have an array of lunch n sorting in ascending order and rotated between 1 to n time. So for instance, the array of nums is considered 0 to 7 might begin with the rotation. I think they are rotation in the ascending order, so that's considered like rotate 4 times. So if rotate 7 times, that's exactly the original value format that we received. Alright, so to notice the rotating array, they are rotating in the correct order. So what I mean by correct order, always ordering from the left to right. So let's call like array of A. So they're moving in the ascending directional order. So given a sorted array of none, we have to return the minimum element of this array. So we have to write the algorithm that runs in O of log n. So yeah, I think the most difficult part is have to write the solution in the log n format. I think same as everyone. My first thinking was, how about we just return the minimum in here? That would solve all the case, most of the case, right? Because let's say if we submit it, that could probably work, but that is not the solution we want. The reason why it is not the solution we want is the minimum in Swift is O of n. So what we want is O was log n. So that is not our approach. So what about we use the sorted? So that will be O of n log n. Let's consider like, let's use a thing called sorted dot first. How about that? That will also solve the problem, but that is not the solution that we want. So by thinking out loud, let's check the three elements together. So we're given like 3, 4, 5, 1, 2. That means from index 2, the left portion of the array is already sorted in ascending order, and the same for the array starting from the index 3 that is also sorted in ascending order. So we have to rotate like 3 times. So let's check this array together. So we're given like 3, 4, 5, 1, and 2. How many times we want to rotate based on the given value? So we are rotating like, anyways, let me update some arrows in here. Right, cool. Okay, never mind. That's much better. So we are moving our sorted array 2 times. Let's consider like 1, 2. So we're here. So move the 1 to the right panel. So that will become like in here. So will be like 1. So 2 probably goes there. And then we rotate 1 more time. There we go. And then the 1 here pop up and then show up in here. So this is totally 3 times, but the output is 1. Right, that makes sense. My first thinking was to make it O of log n. The only thinking I have come in my mind is using the 2-pointer approach. Let's see this asymmetry together. We have 2 pointers from left and right. Let me change the color. And then, how about we use these 2 pointers to calculate if the value of left is probably smaller than the value on the right. So what we're gonna do, we're gonna find the middle. So if we're able to find the middle in here, our case, middle will probably be 7. So what I mean by left and right is I mean of the index of left and right, not the actual evaluation of left and right. So let's consider this is mid, this is right, and this is left. So the condition that will come is we can do the fact check, like if left, let's call left index for mixin, and then right index. So right index will probably always larger than the left index. So that's where the binary search came in with the O of log n. So we'll compare, we'll find the mid. If the mid is greater than, okay, let me highlight. If our mid value is technically greater than the value on the right, what we're gonna do, we will choose the move. It should be green. Oops. I will probably move my left cursor. Why is it not green? From left to mid, +1. So that's the way. So that will help us to narrow down the array into the binary level. So that means like cut the array to the half, and then we got the only need to focus on the array on the right. So we could totally forget this area. And then the same approach we continue. At the end we're able to find the value on the right. Alright, cool, let's start coding on it. Yeah, so to do that we're gonna need the 2 pointer. Let's call like left and right. Left is 0, right will be the name.count. Okay, so to think it out loud, so if we use the right as a name.count, that could cause the index out of bound because array start from 0. So it's better to make it -1 for the safe purpose. And then same, we're gonna check the left and right, and then we find the mid. So the mid will be the, how to find the mid in here. Okay, we have 0 in here. 1, 2, 3, 4, 5, 6. Alright, 6 in here. So the mid is probably 1, 2, 3. So definitely what we can do is we can literally divide the total less index of the array by 2, but that is for the even case. So what about our array is odd number? Odd number mean we have array like 0, 1, 2 or something. Okay, what I mean by 0, 1, 2 is let's consider we have array like 0, 1, and 2. Okay, that will be the count of, okay, let's make it even. So 3 divided by 2, that will not be the half because 3 divided by 2 is definitely 1, so it will stuck in here. So we don't want that. I think in that case, what I can simply do is just do the left plus right minus left divided by 2. So that will give us the actual exact mid. So let's consider if our mid is greater than our value on the right. What do? We're gonna move our left to the mid +1. If not, we move the right to the mid. Alright, if everything went well, we can just return the left. Alright, let's check together and try to submit. Alright, that's probably beats like 100% of the space complexity and time complexity. So technically space complexity is 93. So we get the O of log n for the time complexity. How about the memory, the space complexity with O of 1? Right, that's pretty much for it. Then see you in the next one. Bye.